3 o'clock. Let's get started. I want to welcome everybody to the Apalachicola National Estuarine Research Reserve SciCafe series. This series is a platform to share information about the science being conducted in and around Apalachicola Bay in an informal and casual setting, bringing together residents and scientists to explore different topics. Thank you for joining us today. Our topic is understanding the impacts of sea level rise in Apalachicola Bay. Our program will be about an hour in length with questions about 45 minutes in. However, this is informal, so if you'd like to ask a question, you can type it in the question box or you can raise your hand. We ask that you hold it till the speaker's comments are completed. Today we welcome Dr. Renee Collini. She is a regional coastal climate specialist, a resilient specialist with PLACE, Program for Local Adaptation to Climate Effects Sea Level and Sea Level Rise. She's going to walk us through how to think about these issues. So thank you, Renee, for being with us. And she's suffering from a little bit of getting over laryngitis. So we're going to be patient with her. Take it away, Wayne.
All right. Hi, everybody. Thanks so much. And just a quick recap to make sure you can still see my screen and everything.
Yes, we can.
Okay. Hi, everybody. Thank you so much for having me. I'm very glad to be here, and I'm sorry for the technical difficulties. It seems like no matter how far we get into this pandemic, we still can't make the technology super smooth. I'm also a little hoarse. I've been in a workshop, so just bear with me because I am very excited to be here and to have a chance to talk with you all about changing flood risk in Apalachicola. So just real quick, I want to tell you about my program. I'm affiliated with Mississippi Alabama Sea Grant and Florida Sea Grant and Mississippi State University. And they all fund this program called PLACE. And the purpose of PLACE is to do what we're doing today, right? To help move forward the conversation about how to be more resilient, specifically to sea level rise and extreme rainfall. And when we talk about those things, it's not just about rising seas, but it's also about how it impacts things like hurricanes, nuisance flooding, stormwater flooding, and what we can do both in the built and the natural environments to tackle these issues. And there's a lot of information out there, so much information that actually when you start to take it all in, whether it's models or science or reports, it looks like this. It just looks like a pile of disparate things. And my program's purpose is to help put all these pieces together in a way that we can then move forward on resilience. And I work actually across Mississippi, Alabama, and Northwest Florida because this area has a really similar amounts of expected sea level rise, and the landscape is also very similar. So not just in terms of it's low and flat, and there's marshes and barrier islands, but also the makeup of the communities, the cities, the counties, right? It's fairly rural with interspersed pockets of urban-ish things. It's certainly not, there's no Miamis or Houstons in this region. So that means that there's a lot of lessons learned and sharing that happens across this space. So what does that mean for today? What are we gonna do today? Where are we headed today? Well, the first thing I wanna talk about a little bit is why even talk about sea level rise and talk about our motivation. I also want to make sure that we are on the same page around sea level rise and what it means and how it's moving forward. The next thing I want to talk, we're going to talk about sea level rise in Apalachicola, and then we're going to spend some time talking about what you can do. And of course, we'll have plenty of time for questions. And actually, we're going to have lots of points throughout where we stop and talk about questions. And I just want to make sure that as we're doing that, I'm doing that so that way we're all moving forward together. But before we get too far, I want to know your motivation. I want to know why you want to learn about sea level rise, and I want to know what you want to learn about sea level rise. So just take a few minutes to put your responses in the chat. I want to know why you're here, what you want to learn, why you want to learn it. And Anita, I think oh, now I can see the questions. Great. Okay, so if y'all in the audience want to go ahead and start putting your motivation, what do you want to learn and why do you want to learn it? To make sure that as we move forward today, we tackle all that. We'll just take a couple minutes to do that.
And I can read them out. You see them, Renee?
Yeah, I can see them now.
Great.
All right, we got some questions starting to come in. Keep them coming. I like it. Oh, we got some questions about infrastructure, cost-effective approaches, understanding the scope of our challenges. Great questions. Questions about the local wildlife or the aquaculture? Okay. Looks like we've slowed down, so I'll keep going. But those are good things to know. I'm going to try and answer all of these as we go. The ones that I can't answer, I'll make sure that we circle back to and we get someone else here maybe to answer them. All right, so moving on. I want to talk a little bit about my motivation. So the big thing for me is worsening hazards. We're coastal folks. We know how to deal with hazards. It's something that we've been doing this for a long time, but these hazards are changing. So for example, as seas rise, we're going to see reduced storm drainage. And I don't think we often think about the fact that all of our stormwater systems, for the most part, are gravity fed. And you can see in this little animation here that as seas come up, they cover up those outfalls, and it just slows down the speed at which even rainfall can drain away. And that leaves water up into our yards and our roads and our homes. And we've already been seeing this. You can see here, I just pulled a couple titles right off of the news. There's just a lot of discussion about how rainfall has been changing and how it's affecting. So this is already occurring. Also, again, erosion, which we're used to, is going to exacerbate and get worse. Same thing with storm surge. And it's not a simple addition where as seas come up, if you have a foot of sea level rise, then storm surge is just a foot deeper. You know, we have a low, flat coast, like I said. And so when it's this low and flat, just getting a little bit of water up means a long way inland. So we're talking about whole new areas being exposed to surge. But additionally, our protection on the coast and the things that we have here actually become exposed to that erosion and that dynamics in different ways. And again, in this little animation, you can see how those protections start to break down. And actually, our whole shoreline is reshaped, even by just small amounts of rise. And so all right, so this is what I was talking about with worsening hazards. And that as seas rise, it reduces that ability of the rainwater to drain off. And so this is just a visual to help illustrate that. And then I also have here, just again, some snapshots I took from headlines of just more heavy rainfall issues across the region. And then the next thing I was talking about was the increased erosion, and that as seas rise, even a little bit of sea level rise exposes new areas to those waves and those tides, which causes increased erosion. And then with storm surge, it's not as simple as, oh, if seas are 6 inches higher, then surge is 6 inches higher. It's more complicated, partly because, as you can hopefully see from this graphic, that we have a low sloping coast. So even just a little bit of water up means that water goes a lot farther inland. And so that lets surge expose and hit new areas. And as we have that erosion occurring and it's intensifying, it starts to reshape our shoreline, and it reshapes our defenses and our barriers. And so even again, just a few inches of sea level rise can reshape our coastline, and it really changes what surge looks like and how that coastal flooding kind of occurs. We've also seen just more high tide flooding. Now, this statistic isn't from Apalachicola, it's from Bay St. Louis, but again, here in the northern Gulf Coast, in 2000, they only had 3 days of high tide flooding. And in 2020, they had 22 days of high tide flooding. And so as we keep going, you can also see, of course, there's saltwater intrusion. And I don't have a great image for saltwater intrusion. It's hard to take a picture of water that doesn't look salty. But this is kind of what the impacts look like, right? The infrastructure around us, as it's exposed to salt water, starts to rust and wear out. And we also have salt water getting into our fresh drinking water and into other places where we simply don't want it. But what does that mean for people, right? This is all physical things that change, flooding, etc. But it means changes to health risks. Water being where it shouldn't be and staying there for longer causes serious health problems. It also leads to safety issues. Simply put, driving through lots of water, for example, can be dangerous. There's also those direct damages, not only to our personal things like our cars and our homes, but in things we've invested in as a community like roads and our stormwater infrastructure. There's also economic disruptions, and this takes a lot of different phases, but you can see here, for example, just if the business itself is flooded, then that's going to be a big problem. And economic disruptions also generate reduction in services. So if you take a look at this, this is just sort of a snapshot of an example sort of broadly of like how education is funded. And here you can see that almost half of the revenues that support this K through 12 education comes from local revenues. So if your local businesses aren't generating money and contributing to taxes, that's going to directly impact your ability to have services like that. Additionally, when we have this flooding, it reduces services from those direct services in terms of the people who are supposed to help us and take care of us being able to get to us. And then the last sort of service I want to talk about is, again, that infrastructure we invested in. This is a road. It wasn't a storm, it was just a regular day. And the guy in this truck actually just wanted to go buy some food and buy a couple of tourist knickknacks down the road because he was visiting this coastal town. But he couldn't do either of those because the road itself wasn't accessible. This service that's paid for wasn't there for him. And so not only did he was not able to use the service, again, it all comes back to that economic disruption. But then there's also these cultural impacts. When we think about our coastal spaces, I mean, I know when I go to Apalachicola, I'm thinking immediately of seafood and good views, but just broadly in our region, that's sort of what we represent, right? The food, the views, the boats, the marshes, that space is our home. But there's only so much of this kind of destruction that we can take before those cultural ties start to take a toll aware. And so there was a study done in 2013, and you can see here, I'm going to walk you through it. On these y-axes, the up and down ones, those are people exposed to sea level rise risks. And across the bottom, you're moving from less social vulnerability to more social vulnerability. Now, the colors don't mean anything other than just to indicate, yeah.
I think your slides are lagging just a little bit behind you. We're still on what does this mean for people, just so you have a feel from where we're at.
Oh my, yeah, that's quite a bit behind.
Okay, here
I guess I need to wait.
We're at the vulnerability, the graphs. There's a specific North Atlantic, South Atlantic Gulf.
Yes, yeah, okay. So again, on this vertical axis, that's number of people exposed to sea level rise. And then across this axis, it's social vulnerability. So, the category of either low social vulnerability, so lots of money, economic opportunity, things like that, to highly social vulnerable. So people who don't have as much educational attainment, don't have as much money, that kind of thing. And if you zoom into the Gulf, you can see here that first of all, there's just a lot of people at risk to sea level rise, period, in our region. The other thing is that when you look at these bars, you see that they're comprised of different colors. And those colors represent what at the time in 2013, they felt like the options were for these people in response to sea level rise. And there is a lot of that light blue, which is to abandon. If you go back to the main graph, though, you can see the rest of the U.S. does not look like that. And so that's the whole reason I'm here today. And I think why y'all are here today is that this doesn't have to be that way. This is from 2013. We've already changed the story some, and we can continue to change this outcome. We can preserve the services, the infrastructure, the health, our communities, our cultures. It's going to look differently. We're going to have to live and work and play with water a little differently than we have because seas are coming up into our spaces. But if we get ahead of it, we can have this be something that we grow and change with and not have it be something that happens to us. So to do that well, we got to understand what we're dealing with, right? So one of those questions was getting an understanding of the scope of what's going to happen. So that's what we're going to start with. And I want to make sure that we're all on the same page. So first of all, when we say sea level and sea level's rising, what are we even talking about, right? So sea level is that starting point of water depth. If you think about how there's tides every day and there's waves on top of those tides, and then we have like El Nino years where water's higher or lower, and then we have storm surge, all those things kind of happen around one starting point or mean sea level. And that is what's coming up. So all of those things are happening higher. And we know this because we've been measuring seas using tide stations in some places for over 100 years around the United States. Also, more recently, when I say recently, like in the last 30 years or so, we've been having these satellites that have also been explicitly measuring sea surface height. And so they're able to measure the surface of the ocean and know how things are moving forward. And so often the question is, okay, well, if we know they're rising, we can see them rising with these instruments, why is it rising? And simply put, there's sort of two reasons. One, there's melting land ice. So as land ice melts and enters into the oceans, it just makes all of the oceans higher. Another is that the ocean is getting warmer. And as that ocean gets warmer, if you think back to high school chemistry, you remember cold things, sort of the atoms were slow and didn't move much. But as they warmed up, they would move around more and more and more and more enthusiastically and just take up more space. And so that's called thermal expansion. And so as the ocean gets warmer, it physically takes up more space. And so that's the other reason why seas are rising. But seas aren't rising the same everywhere. Yes, overall the oceans are higher, but where you're at on land and what that land is doing makes a big difference. So you can see here, I hope soon, that these arrows, down means seas look like they're falling at that spot, up means they're rising at that spot. And so it's not only just different directions, but also different amounts. And if we zoom into the Gulf of Mexico, we can see even in the Gulf, we're seeing sea levels change at different rates in our region. So, in Louisiana, of course, it's those big red, scary arrows because the seas are falling really quickly, but in other areas, not as much. If we look at Apalachicola, there's actually been just over 5 inches of sea level rise there between 2000 and 2020. So in the past 22 years, 20-ish years, there's been about 5 inches of rise. And so what that tells us is not only are seas rising so differently in different places, they're rising faster here than they have been in the past. So bottom line, what does sea level rise look like in Apalachicola? Here are projections that we just got updated in 2017 for how seas are expected to rise in Apalachicola, Florida. And so just to orient you, this is feet on this axis, and this is time across here. And as you look, you go from low, intermediate, low, all the way up to the high scenario. So there is quite a range there. And oftentimes people will see that range of, a little over 2 feet to 7 feet and feel like scientists clearly just don't know what they're doing. Why can't we just have a single number for how much seas are expected to rise? Well, there's 3 good reasons for that. One is we don't know how much carbon is going to be in the atmosphere. This graph across the bottom shows time, and on the vertical axis shows temperature and carbon concentration in the atmosphere. And what we can see here is there's this relationship that as carbon goes up, temperature also goes up. Temperature is the blue wiggly line. But the reality is that we can't predict what people are going to do. Our choices now make a big determination of that. And so if we don't know how much carbon is going to be in the atmosphere, we're not sure how much it's going to warm up. And so we don't know exactly how much seas are going to rise. So part of that range accounts for different futures. The other thing is, if you go back to the same graph, that blue wiggly line, that temperature line, it's because nature has wiggle, right? It's not just smooth. April, 28th does not look the same as it did last April 28th, and I'm sure next April 28th will look different as well. There's a range in which all things exist. Nature's wiggly, and sometimes those wiggles line up and amplify each other, and sometimes those wiggles cancel each other out. But either way, we know that these wiggles make for a range of things, not a single number. So some of that accounts for the natural wiggle. The last thing that we're working on here is understanding the ice sheet melt. This is the science that we're still really watching. Some of those scenarios, those upper end scenarios, really are on the fact that there could be some really fast and rapid melt. This was just updated, some of this science with those new scenarios I just showed you. And so we're getting better at this every day, but we still don't know exactly what's going to happen with the ice sheet. So that's more about timing, how much and when. So you can rethink this graph where you're looking at all 5 curves, not as a big range, but more like a framing. This is what's scientifically possible, given what we know of how much carbon there could be in the atmosphere and all the wiggles in nature and the potential for melt from some of those big ice sheets. But it doesn't mean that they're all equally as likely. Just because these things all could happen doesn't mean they're all the same probability of happening. And so we have what we call these likelihoods of being exceeded, right? And I'm going to walk you through this, don't worry. I do hope you can see it before I get too far into it. But basically, we're able to think about some of those things. For example, the temperature, right? So we know if we keep temperature to a certain degree, then that means that like the low sea level rise scenario is still really likely to happen. But as you move into these higher sea level rise scenarios, they become increasingly less likely. And so we know that while the low and intermediate low scenarios are real likely to be exceeded, those other ones, while possible, have a lower chance of happening. And that gives us a lot of power and information around planning. We also have a version where we think about that ice sheet stuff that we don't know. Like if we assume sort of the worst case will happen, we can fold that in and then see how likely some of these scenarios are to happen. So again, just because we know that's the range of what could happen, it doesn't mean they're all equally as likely. So I want to come back to one more thing When we talk about likelihood, I will say right now in Apalachicola, what you're seeing here, this black line is actually the observed data up to 2020 and then extending that trend out into time. And so right now, even though the high scenario is sort of unlikely, we're actually trending a little bit above it. So we're still figuring things out in the northeastern Gulf. Seas are going pretty quickly in terms of increasing and rise, but that's some concrete information we have that we know this range is at least in the right vicinity. But just so you know, the other thing to this, I just wanted to flag, in addition to the seas coming up, we are seeing changes in precipitation as well. And so what that means is that we've seen, not what will happen, but in the past, what's already happened in the past 60 years, there's been a 27% increase in extreme rainfall events. And I think everybody here can attest to having witnessed that in their lifetime. And so that trend is expected to continue into the future. The amount of that is a little bit unsure. You know, is it an extra 10% or another 20%? But we do know it will continue. And so as we continue into the future and we're thinking about planning and flood risk, the changes in rainfall is also a really important thing to keep in mind. That we're going to see less rainy days, but when we have them, they'll be more intense. So I did want to pause and see if there are any questions about the science that I've talked about so far. Next, I want to talk about like actions and that kind of stuff. But before we do that, I just want to see if there are any questions about the science.
You can either raise your hand or type it in the chat. I mean, the question. There's one here now. It says, how will sea level rise affect Appalachia? Oh, no, I'm sorry. That's an old question. Try that.
Mm-hmm. Well, just real quick, the impacts of the aquaculture, I'm really not sure, honestly. I think that some important things to think about will be the suitability of the habitat, you know, the salinity ranges and how that changes will be something to keep up with. But if we're not building hard reefs that have to be set in place, then I think you can think about creative ways to just make sure that the reefs of those areas you're working in are having suitable salinity. We'll get into different approaches for sea level rise resilience. Are there any other questions before I move on?
Not seeing it.
All right, so now let's talk a little bit about the impacts. I was going to do demos, but since the internet is being kind of wonky, I'm just going to skip past that and just simply say that as seas rise, know that high tides will be higher. In some pieces of Apalachicola right now may become permanently inundated. And that the surge, as it changes, it will, like I said, go deeper and be farther inland. One thing that we wanted to ask y'all, I was trying to make this interactive, but the technology has been kind of difficult, is what you wanted to cover next. And so we kind of have two options. We can talk about decision-making in an uncertain future, where we learn more about how to pick a number to plan for and what that looks like. Or we can talk about specific adaptation actions, what individuals and cities can do to take action. Do y'all have any strong preferences? Anita, do you want to just pick one, or do people want to put anything in the chat? Oh, we got to vote for adaptation actions. Y'all keep putting stuff in the questions. Adaptation actions or decision making? And while those are coming in, I'm going to answer Thomas Miller's question about sea level rise affecting barrier islands versus mainland areas in the Northern Gulf. That's a really good question. That barrier islands are very dynamic. They move around a lot, as I'm sure y'all know. And so sea level rise is affecting them. It really depends on how built out they are. Barrier islands are meant to roll over and move back with the coastline. But if there's hardened infrastructure on them, that makes it difficult. And so there's a lot of considerations there about what that looks like, and management actions will really lead to the decisions of how that's going to play out. On the mainland areas, you have a lot more of these combined issues around not only is there coastal flooding, but riverine flooding and rainfall flooding. And so the flooding hazards, I think, are more complicated on the mainland and a little bit more variety. There's a lot more variety depending on where you are exactly on the mainland. Well, I had suspected that's what y'all were going to talk about, so that's what's next on the slide, so that makes it easy. So the first thing is, when we're talking about adapting to sea level rise, one of the big things is supporting community planning and action. And I actually use Apalachicola as an example of that all the time, because before you know where you need to go, what you need to work on, you first have to do planning, get information and data. So like a vulnerability analysis. And Apalachicola actually did a vulnerability analysis to sea level rise that came out in 2017. And then they used that to identify low-lying areas that were at risk, to identify coastal flood areas at risk, and to identify that there was a lot of work that needed to be done around those historic buildings. And then from there was more work taken to make sure that new buildings that were coming in and had to meet those historic building codes also were being built to be flood resilient. And on top of that, we also have work going on to work on adapting the current buildings. And that's what this other bullet is about wet and dry flood proofing. So that was something that Apalachicola specifically explored, was how to either wet or dry flood proof existing buildings and structures. And so basically what wet flood proofing is it just means that it's okay if water comes into a space because it's designed to hold that water, and it's not going to set back your business or anything like that. Whereas dry flood proofing uses physical barriers to keep water out. There's lots of other types of planning though, and hazard mitigation planning, community development planning, all of these things can have an aspect of thinking about what your future looks like and how it's going to look. So just remember that while sometimes it can feel like there's plan after plan after plan, those plans really are building on each other. And another really good example of that is on Dauphin Island, where they've been able to get a lot of federal funding and state funding because they had these plans that built forward on themselves so that they were able to, when they get to each stage, whether for implementation, whether that was building protection or that was supporting community development or economic injection into the community, they knew exactly what they needed and where it needed to go. I was going to play a video about Apalachicola specifically, but I'm going to skip it just because of the challenges we've had. But the next thing I wanted to talk about too for your community is business continuity planning. And y'all may not know that 90% of all businesses in coastal Northwest Florida are small businesses, and they employ over 140,000 people across the region. So small businesses in particular are really important. However, they often don't have the resources that many large corporations do. And so planning to make sure that these businesses know what to do in a case of not just a flood, any kind of hazard, is a really big effort that local chambers of commerce can undertake and things like that to help build connections and bridges and support networks, but also plans. Just as an example, there was a community in Mississippi, or a business in Mississippi, they did a continuity plan, and they actually worked through and did like a dry run, if you will, and they all went over to their secondary location so they could set up and make sure they had everything they needed. And they had everything except for the passwords, because everybody's password was written out on a sticky note on their computer back at the main site. So even though they had all their computers and all the things they needed, nobody could actually get into the system. And so that's an example of how having planning efforts for continuity and practicing and walking through it, not just being a thing that sits on the shelf, can identify ahead of time where there might be problem areas too. So I just wanted to flag, those are some ways that you can help as a big community. The other thing you can do as an individual is think about ways to reduce your risk, whether that's flood insurance or retrofit in your home, looking at future flood risk maps when you're thinking about buying or supporting or doing something like that, and then also thinking about improvements around the yard. So first, let's talk for a minute about flood insurance. In Hurricane Harvey, 80% of the people who sustained flood damages didn't have flood insurance. In Hurricane Sally, more than 50% of flood damages were outside the flood zone. So flood insurance isn't just something that needs to be inside a specific area for people who seem like they're at risk. Right now, so this was before risk rating 2.0, maybe different now, but when I did this a few months ago, when I pulled numbers down, a flood insurance policy outside the flood zone was around $520. And so if you think about the risks that you could be facing from these larger events, as floodplains are changing faster than the maps are, that's not very much investment to think about saving a lot of costs that could come down the road. And of course, right now, most of the flood insurance policies are backed by the National Flood Insurance Program, which means that there's lots of protections and securities that go along with that as well, and ways for your community, go back to that community planning, to actually help bring your cost for insurance down through their work. When we talk about retrofitting, one of the big things is elevating. And so even if you think about like, not just elevating your homes, but the service equipment you have. I've been to Apalachicola quite a few times. I know many of those houses are like mine, 2 or 3 feet off the ground. Some of them are much higher, but sometimes the equipment isn't that high. And so you can make your flood insurance cheaper and just in general reduce the headaches when flooding happens if you just put like your HVAC units and stuff up. And so when we talk about service equipment, it's HVAC, fuel, it's electrical. So if you have your electrical paneling higher, your sewer management, potable water, all that stuff could be elevated. Another thing is, you want to go above the base flood elevation. I can't remember now if there's a freeboard in Apalachicola. I think there used to be. But then there's also protection in place. So these are things like flood walls and shields, tie downs, backflow preventers. So backflow preventers are things that keep the seawater from coming up your stormwater system. Flood walls are what they sound like. They're things that connect to each other like puzzles that you can put around your building to keep flood water out. Now, obviously, these are about waist high, so it's not meant for major floods, but for everyday sort of smaller flooding or more common flooding. There was actually a story about a woman over in Florida who she got this business, and a floodplain manager was telling her in the building there was flood protection stuff that she should be able to put up because it was on the insurance from the previous owner. And she said, no, I don't know what you're talking about. So the floodplain manager went over there, and in a closet, there was this stack of things that she had no idea what it was. And it was actually a flood protection wall. Another thing is looking at future flood maps. Like I said, it's a good way to think about retrofits or buying or planning. Since I can't do a demo, I do have some snapshots here. This is for just the Northern Gulf. It covers Apalachicola. If you click over here on this button, you can actually look to see how different historic storms look with current day versus future. I'm hoping y'all are caught up with me, but essentially these 4 panels show Hurricane Katrina, which was less of a big deal for y'all, but it was a big deal in other places, under different amounts of sea level rise. You can also look at that 1% or the 100-year floodplain. And as you swipe back and forth, it will show you how, with sea level rise, that is expected to change. The last thing I wanted to touch on, and if my memory serves, really right now, Apalachicola is still in that space where a lot of the challenges are coming from rainfall. And so improvements around your yard, especially if lots of people are doing it, can make a big difference. One thing to consider is reducing impervious surface. So using gravel or pervious concrete or gaps in decking, all those things can help make sure that the water is getting absorbed and not being run off and having to be forced to be moved somewhere. Another thing are rain gardens. I can't undersell these enough. I think they're beautiful, but also they absorb water so quickly, and they're designed in a specific way and with certain plants to make sure that they can be. And actually, the Extension Service in Florida has developed a guide specifically for Northwest Florida on how to design and build these rain gardens. There's also rain barrels, so collecting that water off your house and using it for different types of things around the yard, gardening. There's lots of options. Or even just letting that rain distill into the yard slowly instead of all of it coming down at once. And then for those of you who have shorelines, using living shorelines. So whenever we use hardened structures, they reflect back all that energy. And the other thing is, if seas rise, those bulkheads and those hardened shorelines are static, they're stuck. They can't grow and move and expand, whereas living shorelines can. And we found that, there's going to be more often those high water and high intensity events. Living shorelines over a 30-year lifespan are about 3 times more cost effective than a wooden bulkhead. So that's just reducing your cost when having to deal with these storms more often. And again, one of these may not seem like it's a big difference, but having all of these in one place or having lots of these things being done by lots of people in one city all add up to really make a big difference on the amount of rain that's entering the system. So I guess my parting thoughts for y'all is sea level rise is exacerbating hazards we're already experiencing. Again, we're coastal people, we know how to do this, but this is new and it's getting more challenging. We can be ready for it though. We have the knowledge, we have the tools, we know what's coming, and it's just a matter of making sure that we're tackling both ends of the system, that our shorelines and our infrastructure are ready, and also upland, we're reducing the stress, reducing the rainfall runoff and that kind of thing. And the big thing is, we have to talk about it. Resilience doesn't happen on accident. It takes folks like yourself coming to meetings like this and moving things forward and making sure that we're progressing. I want to point out that, there's this scale. It's a study that's done every year on where people are about climate, how alarmed they are versus if they're just fully dismissive and everything in between. And one thing to note is that even though more than half of the people, more than 2/3 of the people are concerned, only 1/3 of those people talk about climate change and sea level rise with their friends or family. And so that means that even though we're all, or many of us are concerned or want to do something about this, we're not talking about it, and it's not going to move forward unless we do it. So I'll stop there. I'll stop sharing my screen so I can answer any questions that may be there. But yeah, I'd love to answer any questions that are there.
I'm just letting people absorb here. I put in a link to the University of Florida IFAS Rain Garden resources. I know I would like to see your slide again on the Apalachicola sea level rise.
Yeah, of course. Can we pull it up?
Yeah, that'd be great.
And so you can see that just looking ahead over the next 30 years, we're expecting to see sea level rise be at least a foot and a half compared to the year 2000 in Apalachicola. But right now we're actually trending a little higher than that, maybe a little over a foot and a half. That acceleration has been happening not just in Apalachicola, but basically from Bay St. Louis in Mississippi around to Cedar Key. And the researchers aren't quite sure why, but that is why the observations are even a little higher than these projections in the near term. In the long term, I think it'll all even out. But yeah, in the short term, if we're thinking about restoration projects and things like that, that black line may be a little bit more in line with what you should plan for.
All right. And I know we've talked about these intermediate, the low, intermediate low, intermediate high, and high scenarios.
Mm-hmm.
This is handy if you're planning a project, and for instance, you would have or why don't you explain it, Renee, the intermediate high and the high tolerance versus low tolerance.
Yeah, and I actually have some slides for that. I wasn't sure how much folks would want to see that, but when you think about projects and how much risk you're willing to have, that's called your risk tolerance. And you can think about things like how expensive is it, how critical is it that people use it, how many people are using it. And so if all those things are, lots of people use it, it's super critical, it needs to last for a long time, that means you have a low tolerance for risk. And so if you have a low tolerance for risk, that means you really, really, really don't want it to flood. But if you have a high tolerance for risk, say like a boardwalk, or if you've got a little dock outside your house and it's not a super big deal, you have a high tolerance for risk. It's okay if it floods, it's not going to be that big a deal. But then you can connect those exceedance probabilities we talked about. So if you have a low tolerance, you want to plan for some of these things that have a low, I mean, it's really unlikely that it will happen, but it could happen. And so you want to be absolutely ready for it. But if you have, say, like moderate tolerance, so like, for example, when I was buying my house, this is where I felt, because it was expensive to me, but it wasn't like it was a multi-million-dollar project. And I needed it to last at least 30 years, but it's just serving my family, not a whole county. So I actually planned for the intermediate sea level rise scenario when I was buying my house. And then if you have a high tolerance for risk, you're only going to plan for these things that you're really sure are going to be exceeded. Just really avoiding those things to make sure that you can avoid that is really likely to happen, but not plan for much more than that. That makes sense?
Yes, that's great.
And we actually have this example here where, so like, say if you're making a hospital in 2020 and you want it to last 50 years, you'd go out to 2070, and then for me, a hospital is a low risk tolerance situation. You really want it to work, and it's really critical. So you'd go up to some of these higher scenarios. So now, instead of planning for this wide range of things, you're just really looking at about 3 feet of sea level rise over the next 50 years, and that's what you plan for in this particular county.
That's a great way to look.
Rebecca Dolan wanted to know if you could summarize quickly the alternative second half of your talk.
Yes, I can. So the alternative other half, you just saw part of it, Basically, making decisions in an uncertain future isn't new. You know, we've got lots of other areas that we can draw from to think about this. And so one is if you want to know like how much sea level rise to plan for a specific project, you could use risk tolerance, which is what we just talked about. Another option is scenario planning. And that's where you look to see like, okay, if this is my decision of how I want to, say, restore a marsh or how I want to build a certain flood protection berm, you look at how that fares under a variety of sea level rise scenarios, and then maybe pick the one that works well or okay enough under all those scenarios, even if it's not the best under any of them, because then you know no matter what happens in the future, what you picked will work out at least a little bit. It also helps you identify where things just absolutely aren't going to work in some cases, and so you know to avoid them. And then the third option, again, it's much easier to show y'all. I hope you can still see my screen. It's called an adaptation pathway. And so what that means is that you will basically look at all your choices. So in this case, this is a conceptual diagram of a community that was trying to keep their barrier island from breaching at this specific spot. And they came up with these different strategies that cost more and more money. But then they looked at how much sea level rise these different strategies could take and still work. And so you can put them in this pathway. So as you actually observe changes in sea level, then you can go on to the more expensive and more costly strategies. And this is really great for dynamic areas like dunes and beaches and barrier islands, because the reality is you're one hurricane away from the whole shoreline looking very different in these really dynamic systems. And so it doesn't make sense to take a risk tolerance approach there, because if you plan for 30 feet of sea level rise today and then the whole thing looks different in 2 years, you know, you might have wasted a lot of money. So using these adaptation pathways lets you build on your strategies, and all these strategies are related to each other, but you don't have to actually take action until you've seen that much rise. So I was going to kind of get into the depths and the pros and cons of each of those three strategies: risk tolerance, scenario planning, and adaptation pathways. And I can send a PowerPoint along, Anita, if you'd like, that has some of that you could share with folks.
That'd be great. We can send it out. We have everybody's email. We can send it out. And if you have any question, I'm sure, any questions, I'm sure Renee included her contact information in the slides, or I have it. And of course, now the slides are advancing and all your animations
Everything's
are
working great now.
in the last 10 minutes.
I do want to make a plug for the work that this community has done, and there's a video on it. If you go to, I don't know how to share it with everyone, so I'll put it in the questions and hopefully it'll work. But if you go to bit.ly/future flooding, you can see the work that was done in Apalachicola.
Yeah.
There, everyone should be able to see it now, hopefully.
And I can put it in the email also.
Okay, yeah. It's a great video. There was some cool stuff done.
I really want to thank everybody, especially for your patience. Also, if Alicia and Kennedy could turn on their cameras just for a brief second, I'd like to thank them for helping produce this meeting. It takes years off our lives. Thanks, guys. When it's not working right, it's not fun, but we made it through, and we will get you the slides. And Renee, thank you so much. And please join us for our next SciCafe, which will be on May 26th, and it will be about the oyster core and their project. We have a demonstration aquaculture lease. We'll actually be serving oysters at Estuaries Day, which is on May 6th, that they've grown. So thank you, everybody. Especially thank you for your patience. And Renee, thank you so much for your presentation.
It was my pleasure. If y'all have any other questions, please reach out.
She's here to help. So if you have any questions, professional or personal, we'll try to get you the answer.